The magnificent Burj Khalifa is resisting a strong sandstorm of 100 kilometers per hour. A quick tour below the beautiful petals, you'll come across its foundation, a structure with a whopping depth of a 10-story building. Surprisingly, the foundation of the Burj Khalifa has to carry electricity 24/7. Any small issue with the flow of electricity will weaken its foundation, and the result could be catastrophic on a heavy windy day. Interestingly, the raft of the foundation is as thick as 2 human beings. Even though the raft looks like a simple structure, constructing it was a massive task. This is mainly because a huge amount of concrete had to be poured in a single volume. The construction of this raft started with the placement of steel rebars. The next step was pouring in the concrete, which was no easy feat in the 40-degree heat in Dubai. That's why the engineers executed this work during the night time. They also mixed the concrete with ice cubes while pouring it. The process of concreting the entire raft was done in 4 separate parts, each for a period of 24 hours. There are many more challenges present in front of the Burj Khalifa's chief design engineer, Mr. Bill Baker. First, let's solve the biggest challenge: soil settlement. This is what would happen if their design calculations for settlement went wrong. In normal building construction, engineers always find something called hard strata, a hard soil where the building can rest during the construction phase. The weight of a building increases, and it's normal that the building settles down by a few inches. Let's observe the building settlement. One more time. During this process, the soil below the foundation gets compressed and settled. Now the soil can produce proper reaction force and balance the building weight. Now let's take a cross-section of Dubai's soil. It's just loose sand and weak sedimentary rock. Even after digging 140 meters deep, the engineers failed to find strong hard strata. If the Burj Khalifa engineers had constructed a normal raft foundation on this site, it would settle down a lot. The chief engineer, Bill Baker, came up with a simple solution for such a massive issue: the frictional force of the surrounding soil. Here Mr. Bill Baker is trying to pierce through the sand using a sharp and thin rod. It's a common observation that after a distance the rod won't go down. This is due to the increased frictional force provided by the surrounding sand. As the rod goes down to generate the frictional force, he added a number of piles below the raft foundation. The depth of these RCC piles is equal to 10 floors of the Burj Khalifa. Now immerse the foundation inside the soil and take a cross-section of it. Let's test this foundation. These piles generate frictional force against the weight of the building with the help of the soil reaction force. The raft pile foundation would reach settlement much earlier and within safe settlement limits. When the Burj Khalifa's construction was complete, it had a settlement of just around 5 centimeters, which is quite safe. The next big challenge is how to construct these piles with perfection, making the design a reality for the construction of the piles. They first started with drilling a hole with an auger excavator. The blades of this device perfectly remove the soil. However, Mr. Baker faced an issue: the groundwater of Dubai, due to the heavy machinery around the borehole, would collapse and fill in with salty groundwater. The solution was quite clear. As the soil was excavated, they simultaneously poured a drilling fluid through the auger shaft. This creates a slurry. The slurry, being denser than water, exerts a hydrostatic pressure on the walls of the borehole. Thus, it resists the soil collapsing. Now that the borehole is ready, the workers placed a temporary hollow steel cylinder to hold the soil intact for concreting. Then they placed in the steel reinforcement bars welded as a long cylinder. In normal concreting, the laborers must use concrete vibrators to make the concrete. Compact usage of these machines is impossible in such deep boreholes. This is why the SCCC-60, a special kind of concrete that flows like a liquid, is used for the piles. The concrete was poured in with the help of a tremie pipe. The construction of the foundation alone took 2 years. The entire sequence of foundation construction for the Burj Khalifa are illustrated. Here we have now achieved a good foundation design to hold up the tallest building in the world in loose Dubai soil. Although this piled raft is standing against the gravitational pull, Dubai's heavy sandstorms are yet another test. The piled raft design developed will fail during a heavy sandstorms. If you want to strengthen this tower to prevent it from falling, would you add glue to the center of the base plate or to the edges? When the Burj Khalifa is glued at the center, it is falling down because of the wind force. When the building is glued at its edge, it's standing strong in the original Burj Khalifa design. A similar technique can be applied to the pile design, just increase the number of piles in the wing area. Due to this neat design change, the Burj Khalifa is able to withstand wind velocities of up to a whopping 240 km per hour. Interestingly, to analyze this optimal placement of piles, the engineers performed rigorous pile load tests, which involved applying heavy load on a temporary test pile and studying the settlement. These tests spent over 6 months and occurred at 23 spots on this Burj Khalifa location. Now the answer you have all been waiting for: why does the Burj Khalifa foundation have to carry electricity continuously? If this is not done, the salty water seeping from the Persian Sea will corrode the rebars inside the piles. To overcome this problem, they use the physics behind batteries electrolysis. They made these rebars cathode and used titanium mesh as a sacrificial anode. This prevents the corrosion of rebars, but it heavily corroded the anode metal. After years, the anode would need to be replaced. Thank you for watching. For more informative videos, like and subscribe our channel.